Okay, so today this is the chapter we are going to discuss. We are able to discuss the preparation properties of amines, cyanides, preparation properties, isocyanates preparation properties, and nitro compounds. So these are the topics which we are going to cover under this organic compounds containing nitrogen. Okay, so this is a chapter we are going to discuss. Organic compounds containing nitrogen. Okay, let us enter into discussion. Okay, now you see that is preparation of amines. Okay. So amines preparation as well as chemical properties. So let us have a look about this preparation of amines as well as chemical properties. You know that is amines is having the formula. What is the formula of amines? We have that is RNH2 is the formula for the amines. RNH2 is the formula. Okay. Amines, the common name we are calling it as alkyl amines. Alkyl amines is the common name. IUPAC name is alkanamines. Okay, and the classification of amines you see here. Amines, how it is classified? Amines are classified into that is two types. One is alkyl amine, other is aromatic amine. Okay, alkyl amine as well as aromatic amine. This is general classification. Again, this alkyl amines is classified into three types. Okay, again this alkyl amine is classified into three types. What are those types here? We have that is primary amine. It's classified into primary, secondary, tertiary, as well as quaternary ammonium salts. Okay, again alkyl amines are classified into that is primary amine, secondary amine, tertiary amine, and quaternary amine. So this is a classification. Okay, so generally the amines are classified into two types: alkyl amine as well as aromatic amine. Again, the alkyl amine is classified into primary, secondary, tertiary, and quaternary. Okay, so let us discuss the preparation of the amines. See how amines are prepared. So these amines are prepared from that is carboxylic acids. It can be prepared from cyanides. Okay, it can be prepared from carboxylic acids. It can be prepared from cyanides, and it can be prepared from nitro compounds. It can be prepared from that is Gabriel phthalimide synthesis. In this, amines are prepared. That is, you have to remember the names. By there are three named reactions are there. Amines can be prepared from that is Gabriel phthalimide synthesis. It can be prepared from Gabriel phthalimide synthesis. It can be prepared from Mendius reduction. It can be prepared from the Schmidt reduction. Okay, so this is the preparation. Okay, so let us enter into preparation. He said here. So when you are taking a carboxylic acid, this carboxylic acid upon treatment with hydrozoic acid, N3H, what you are calling this as? N3H, we are calling it as hydrozoic acid. So upon treatment with concentrated H2SO4, we are going to get the amine. Next, you are taking the cyanide compounds, alkyl cyanides. Alkyl cyanides upon reaction with that is hydrogen in the presence of nickel. Hydrogen in the presence of nickel. Okay, and sodium in the presence of ethanol. So when you are treating with this compound, what you are going to get the amine. Next, nitro compounds upon treatment with that is tin in the presence of HCl. Okay, followed by lithium aluminum hydride. So you can make use of this tin in the presence of HCl or lithium aluminum hydride. We are going to get the amine RNH2. Next, in Gabriel phthalimide synthesis, we are taking the phthalimide and we are treating with KOH, the presence of alkyl halide, followed, and we are going to get the amine RNH2. So these are the four methods by which we can prepare the amines. Amines can be prepared from carboxylic acid, So the reaction name is Kunit reaction. Amines can be prepared from cyanides. The name of this reaction is Mendius reaction. Okay, the name of this reaction is Mendius reaction. Amines can be prepared by, that is from Gabriel's aramide synthesis. Amines can be prepared from the Nitro Compounds. Next, let us go further. That is that carbylamine chemical properties of amines. Chemical properties. So in chemical properties, we can see these amines will react with the, that is chloroform. It can react with the chloroform in the presence of KOH. So it can be reacts with the, that is chloroform in the presence of KOH. This reaction we are calling it as carbylamine reaction. In carbylamine reaction, the amine is converted to isocyanate. The amine is converted to the isocyanate. Okay, in carbylamine reaction, the amine is converted to isocyanate. And amines can react with aldehydes. Amines can be reacts with the aldehydes, and you are going to get the, that is a compound called, that is Schiff's base, that we are calling it as aldimine. That we are calling it as aldimine. Okay, so this is two important chemical properties of amines. When amines are treated with chloroform in the presence of KOH, that reaction we are calling it as carbylamine reaction. Here the amine is converted to the isocyanate. Next, when amine is reacting with aldehyde, so what you are going to get? You are going to get the, that is Schiff's base. We are calling it as aldimine. Next, let us go for the basic nature of amines. This is very, very important because in every examination there will be a question based on the, that is basic nature of amines. Very important this. So definitely, if a question is coming from the amines chapter, so there is a chance of, there is a 90% chance of that question will come from the basic character of amines, because the basic character of amines are having that is exceptions are there. The basic character of amines, it is having four orders, four different types of orders based upon the, that is type of amine, and based upon the, that is aqueous solvent. Okay, let us discuss the basic nature of amines. So here one thing you have to remember, that is basic nature of amines. So if you are taking the basic nature of amines, usually the aliphatic amine is having more basic character. Aliphatic amine is having more basic character compared to ammonia. Next, ammonia is having more basic character compared to aromatic amine. So this is the order. That means if you are taking this aliphatic amines are more basic. So aliphatic amines R and H2, this is more basic compared to the, that is ammonia. Next, ammonia is more basic compared to aromatic amine. So among this, which is having the least basic character, aromatic amine. So this is the least basic. More basic, which is having more basic, this one. Aliphatic amine is having the more basic character. Understood? Okay. So of all this, which is having, that is basic characteristics, aliphatic amine is having more basic. Okay, compared to ammonia, because aliphatic amine is attached to the plus I group. Is attached to the plus I group. Plus I group is the electron releasing group. So it will increase the electron density on the nitrogen. Thereby, it will increase the basic character of this nitrogen. And if you coming to the aromatic amine, in aromatic amine, this NH2 is attached to the sp2 carbon. sp2 carbon is having electronegative character, so it will pull these bonding electrons. Okay, and thereby making this nitrogen that is least basic in nature. Right. Next, this is the first order. Next, second order. You take the, that is tertiary amine is more basic. Tertiary amine is more basic compared to secondary amine. Secondary amine is more basic compared to primary amine. And primary amine is more basic compared to ammonia. This is the order. Okay. Second order. This is the second order. First order is this one. Remember, this is the second order. So this is the order which is in the gas phase. When the amines, when we are testing the amines in the gas phase. Okay, this is the order. Tertiary amine is more basic in the gaseous medium. This is more basic. Tertiary amine is more basic. And tertiary amine is more basic in this one. Next, which is least basic here? That is, this is least basic. Primary amine is the least basic. This is in which phase? Gas phase. Again, if you are testing the basic character, okay, this is the second order. if you are testing the that is basic nature of amines in the liquid phase or aqueous phase, what is the order? Secondary amine is more basic. Secondary amine is more basic than primary. Primary is more basic than tertiary. Okay, and tertiary is more basic than NH3. Okay, when this is in aqueous phase, and one more point also is that, and it should have CH3 as substituent. If CH3 as substituent, this is the order. Understood? So it should have that is CH3 as a substituent here. Understood? If CH3 as a substituent is there, then only this is the correct order. Suppose instead of CH3, if C2H5 is there, if instead of CH3, if C2H5 is there, then what will be the basic character of amines? Instead of CH3, if C2H5 is there, so here what is the order it is following means here also that is secondary amine is more basic compared to tertiary. Here tertiary will come and followed by primary, okay, followed by primary and followed by NH3. So it is also aqueous phase. And when this order will follow, when C2H5 is present as substituent. When C2H5 is present as substituent. Understood? So this is the order. So finally, I am going to that is conclude that. So here you have to remember these four orders. These four orders are very important in this one. Okay. Once again, I will explain this one. These four orders. That is. So here usually amines are that is tertiary amine is more greater than secondary amine. Secondary amine is more greater than primary amine. Primary amine is more greater than NH3. When it is in gas phase. This is the order. Okay, in aqueous phase, again it is two types. If you are taking an aqueous phase, it is of two types. When you are taking methyl as substituent and when you are taking ethyl as substituent. When you are taking methyl as substituent, what is that is order of the amines means secondary is more greater than primary, primary is more greater than tertiary, tertiary is more greater than NH3. When you are taking methyl as substituent. Okay, alkyl group when CH3 is present as an alkyl group. Suppose when alkyl group is C2H5, what will be the order? That is secondary is amine is more basic than tertiary amine. Tertiary amine is more basic than primary amine. Primary amine is more basic than NH3. So this is the order, right? Okay, next let us go for the next question. Next screen share. Next screen share. Okay, this is the next screen share. So in this, we are going to discuss about that is isocyanates, isocyanates as well as the nitro compounds. Isocyanates, nitro compounds, preparation as well as the properties. Okay, let us discuss about this. Okay, let us discuss the that is cyanates. We will discuss first. Thereafter, we will go for the isocyanates. Fine. Next one is very important. That is isocyanates. Sorry, cyanates. So here, let us discuss about the that is preparation properties of this isocyanates. So before going to that is preparation properties of this cyanides. Okay. So before going to this cyanides, so let us discuss about that is um, test, that is a distinction test for the amines, separation of amines. We will go for this one. Separation as well as the, that is a distinction test for the amines. Because we have completed preparation properties of amines. So in the last screen share, I have explained about the preparation of amines as well as properties of amines. And I explained about the basicity of amines also. Now, in this screen share, I am going to explain first about this separation of amines, separation of the amines, and followed by the distinction test of the amines. Thereafter, we will go for the other compounds. Fine. So, how the amines are separated? So, amines are separated by, that is by Hoffman's method. Hoffman's method, we can separate the amines, as well as by Hinsberg's methods also we can separate the amines. So in Hoffman's method is a method which is used for the separation of primary, secondary, and tertiary amines. Okay, separation of primary, secondary, and tertiary amines. Here, what you have to, that is in the Hoffman's method, what is the reagent we are taking? We are taking the reagent called, that is diethyl oxide is the reagent we are taking. This is the reagent we are taking. Diethyl oxalate is the reagent we are taking in the Hoffman's method for the separation of the primary, secondary, and tertiary amines. So here, the primary amine will react with this diethyl oxalate and it will be converted to the oxamide. It will convert to a compound called oxamide. And the secondary amine, okay, will react with this diethyl oxalate and it will be converted to the oxamic ester. It will convert to the oxamic ester. Now, if you are taking the tertiary amine, so here it won't show any reaction. Tertiary amine won't show any reaction. Okay, tertiary amine won't show any reaction. Primary amine reacts with this Hoffman's reagent, diethyl oxalate, and will convert it to oxamide. And secondary amine will reacts with this diethyl oxalate and will convert it to oxamic ester. And tertiary amine, there is no reaction. Right. So this is the separation of by Hoffman's method as well as by Hinsberg's method. We can separate the primary, secondary, and tertiary amines. Next one we have, that is Hoffman's ammonalysis. What is the next one? That is Hoffman's ammonalysis. This Hoffman's ammonalysis is nothing but it is a reaction. So it is a reaction between an alkyl halide. It is a reaction between an alkyl halide and it will ammonia. Is a reaction between an alkyl halide and ammonia. So this alkyl halide and ammonia, both it will react. Alkyl halide and ammonia, both it will react. And what you are going to get here? So here you are going to get a mixture of amines. You are going to get the mixture of amines, that is primary, secondary, tertiary, and quaternary amines. Hoffman's ammonolysis, alkyl halide is reacting with ammonia, and you are going to get the mixture of amines, primary, secondary, tertiary, and quaternary. Next, we have, that is Hoffman's bromamide degradation reaction. So what is this Hoffman's bromide degradation reaction? Next we have, that is Hoffman's bromide degradation reaction. In Hoffman's bromide degradation reaction, okay, so we are taking, that is a primary amine. Primary amine will react with bromine in the presence of KOH. Primary amine is going to get reacts with the bromine. Okay, it is reacts with bromine, the presence of KOH, and thereby what happens? This amide is converted to the amine. Amide is converted to the amine in the case of Hoffman's bromide degradation. And we have, that is other reaction called Hoffman's mustard oil reaction. Okay, in this Hoffman's mustard oil reaction, what we are doing means we are taking this amine. Okay, yeah, amine is reacted with carbon disulfide in the presence of mercury chloride. And we are heating this mixture. We are heating the mixture of amine, carbon disulfide, and mercury chloride. We are going to get a compound called alkyl isothiocyanate. We are going to get a compound called alkyl isothiocyanate. So this is a alkyl thiocyanate. Alkyl thiocyanate group, this we are calling it as. N double bond, C double bond, yes. This we are calling it as alkyl that is isothiocyanate. Okay, what is the name of this group? Isothiocyanate. The name of this group is isothiocyanate. Okay, isothiocyanate and HGS and 2HCl. So this is the that is from which we can separate the that is amines. Okay, so amines all these are the Hoffman's reaction. So by from okay, there are four types of Hoffman's reactions are there. One is Hoffman's method, which is used to separation of primary, secondary, tertiary amines. Other is Hoffman's ammoanalysis. In Hoffman's ammoanalysis, what we are doing is we are reacting, that is alkyl halide with the ammonia. Okay, and we are going to get the primary, secondary, tertiary, and quaternary amines. And in Hoffman's bromide degradation reaction, what we are doing, we are taking an amide and we are reacting with the bromine in the presence of KOH, and we are going to get the amide. And in Hoffman's mustard oil reaction, this amine is reacting with the carbon disulfide in the presence of mercury chloride, and we are going to get an functional group called isothiocyanate. So with the name Hoffman's, how many types are there? Four are there. Hoffman's method, Hoffman's ammoanalysis, Hoffman bromide degradation reaction, and Hoffman's mustard oil reaction. Okay, so this is about that is Hoffman's reactions. Next, let us go for the distinction test of the amines. So how the amines are distinguished? Okay, just a minute. So here, these are the distinction tests for the amines. So that means how the primary amine is distinguished to secondary amine, or secondary amine is distinguished with the tertiary amines. So how the primary amine is distinguished with secondary, secondary is distinguished with tertiary. So you have the distinction test for alcohols. What is the name of the test? Distinction test for alcohols. Distinction test for alcohols. What is the name? Lucas test, right? Lucas test is used the test which is used to distinguish primary, secondary, and tertiary alcohol. Right. Like that, we have distinction test for the this amines also. So this we are calling it as Lieberman's nitrosol test. Very important. This is. This we are calling it as Lieberman's nitrosol test. This is the test used for the distinction of the primary, secondary, and tertiary amines. What is the name of this test? Lieberman's nitrosol test. Okay, so here the nitrosol functional group is will be formed. So this is the test used for the distinction of the primary, secondary, and tertiary amines. For alcohols, what is the test we are using? We are using the Lucas test. Lucas test is a test used for the distinction of the primary, secondary, and tertiary alcohol. Likewise, we have a test to distinguish primary, secondary, and tertiary amines. So that test we are calling it as Lieberman's nitrosol test. Very important, this test. Okay, so here let us see the how the primary amine will react with the that is Lieberman's nitrosol test. What is the compound we are going to get? So if you see this reaction here, okay, so if you see this one, so this what is the name of this compound here? Lieberman nitrosol test. What is the name of this compound? This we are calling it as nitrous acid. Nitrous acid. The name of this compound is nitrous acid. So this is the Lieberman's reagent. In Lucas test, what is the Lucas reagent? You know, in Lucas test, what is the Lucas reagent? Concentrated HCl in the presence of anhydrous zinc chloride. Like that, in Lieberman nitrosol test also, there is a reagent called nitrous acid, HNO2. This nitrous acid is reacting with the primary, secondary, and tertiary amine. So primary amine, when it reacts with this nitrous acid, it will convert into alcohol. It will convert it into alcohol. Okay, and nitrogen gas is evolved and H2O is formed. And here exception is also is there. Exception is very important. Methylamine won't give alcohol. Okay, methylamine form methyl nitrite or dimethyl ether. Okay, in primary amines, all primary amines won't form alcohol. Okay, ethylamine will form methyl alcohol, but not methylamine. Methylamine will form methyl nitrite or dimethyl ether. This is very exception, very important. This in Lieberman nitrosol test, all primary amines won't give alcohol. Okay, the methylamine except methylamine, remaining all primary amines will give alcohol with the nitrous acid. Next, secondary amine, how it will react with this nitrous acid. Secondary amine, it will react with the nitrous acid, and thereby we are going to get a compound called that is nitrosodialkylamine. We are going to get a compound called nitrosodialkylamine. The formula for nitrosodialkylamine, this is the formula R2NNO. This is the formula for the nitrosodialkylamine. Okay. Next, coming to the that is tertiary amine. So how tertiary amine will react with this nitrous acid? Tertiary amine will react with this nitrous acid. It will form first salt, because acid plus base, what you are going to get? You are going to get the salt. Nitrite salt you are going to get. This nitrite salt on heating, it is breaking into two compounds. One is it is converting into alcohol, other it is converting into nitrosamine. Okay, this compound we are calling it as nitrosamine. The nitroso group means N double bond O group. Okay, if a compound containing this group N double bond O group, that compound we are calling it as nitroso. That compound we are calling it as nitroso. Nitrosoamine we are going to. So this is the test for the distinction of the primary, secondary, and tertiary amines. So by Lieberman nitroso test, how can we distinguish primary, secondary, and tertiary amine means? So primary amine reacts with the nitrous acid, and we are going to get the alcohol, and along with the evolution of nitrogen. Okay. But methylamine won't give this reaction. That is the exception. Methylamine, when reacts with the nitrous acid, we are going to get methyl nitrite or dimethyl ether. That is first. Secondary amines, how it will react with this nitrous acid. That is in how it will show Lieberman nitroso test means secondary amines will react with this nitrous acid, and you are going to get N nitrosodialkylamine. What you are going to get? N nitrosodialkylamine. So this is the compound you are going to get. Okay, N nitrosodialkylamine. This is an yellow oily liquid. Tertiary amine will react with this nitrous acid, and thereby you are going to get a salt. That salt, again, when we are heating, it will break into two compounds. It will break into alcohol. It will break into nitrosoamine. Okay, it will break into alcohol. It will break into nitrosoamine. So this is the test. Primary amine will form. What will primary amine will form? Primary amine will form alcohols. Secondary amine will form, that is the nitrosodialkylamine. Okay, N-nitrosodialkylamine. Tertiary amine will form nitrosoamine. Okay, so this is the test. Next, Hinsberg test. So this is the test already you know. You have studied in your syllabus. Hinsberg test. What is this Hinsberg's test? So in Hinsberg's test, we are using a reagent called, that is a Hinsberg reagent. What is Hinsberg reagent? Benzene sulfonyl chloride is called. We are calling it as Hinsberg reagent. Benzene sulfonyl chloride. This is an Hinsberg reagent. So this Hinsberg reagent, okay, it is also used for the separation of primary, secondary, and tertiary amine, and it is also used for the test for the primary, secondary, and tertiary amine. So Hinsberg reagent, upon reacts with the Hinsberg reagent, upon it is reacting with the, that is primary amine, so it will form a clear solution, and upon reacts with the KOH, it will form the soluble salt, that we are calling it as primary amine. Next, Hinsberg reagent, when it reacts with the secondary amine, you are going to get the PPT. The PPT upon dissolving KOH, no reaction, that is secondary amine. In tertiary amine, we are not getting the any Hinsberg reagent. So the tertiary amine won't react with the benzene sulfonyl chloride. Primary amine, when it reacts with the benzene sulfonyl chloride, what you are going to get? You are going to get the clear solution that is soluble in KOH. You are going to get the soluble salt. Secondary amine will react with this Hinsberg reagent, and you are going to get the precipitate. Instead of clear solution, you are going to get the precipitate. Primary amine will give clear solution with Hinsberg reagent. Secondary amine will give PPT with the Hinsberg reagent. That PPT, when it dissolves in KOH, it is showing no reaction. Tertiary amine, won't react with the Hinsberg reagent, because in tertiary amine there is no hydrogen. Okay, there is no hydrogen, so no hydrogen is present. All this will be attached with the alkyl groups. No hydrogen is present. So no hydrogen, because of no hydrogen, it won't react with the Hinsberg reagent. Okay. Tertiary amine does not have a hydrogen attached to nitrogen. Okay, there is no hydrogen attached to nitrogen. That's why it won't react with the Hinsberg reagent, tertiary amine. Whereas secondary amine and primary amine, it will react with Hinsberg reagent. Primary amine will react with Hinsberg reagent, and it will form a clear solution. That clear solution is soluble. Upon treatment with KOH, you will get the soluble. Secondary amine will react with the Hinsberg reagent, and you are going to get the PPT, precipitate, that is insoluble in KOH. No reaction. Tertiary amine is no reaction. So this is the test that is for the primary, secondary, and tertiary. Okay, if you have any doubts, please message in the chat box. Let's go for the Okay, let us go for the next screen share. Next, let us go discuss about that is this three other different functional nitrogen containing functional group. What are those functional groups? So here, okay, so we have that is isocyanates, nitro compounds, as well as preparation of the isocyanates and preparation of nitro compounds. Isocyanates, how it is prepared? Isocyanates, so it is prepared by taking that is alkyl halide, and upon treatment with the AgCN, alcoholic AgCN. This is alcoholic AgCN. You are going to get the isocyanate. You are going to get the isocyanate, and you are taking the that is amide, N substituted amide. This is N alkyl substituted amide. This is N alkyl substituted amide. This upon heating with POCl3 also you are going to get the isocyanide. Right. Next, let us go further. That is nitro compound. So nitro compounds. So here, what you are going to discuss is here nitro compounds means that is a compound which can RnO2. This we are calling it as nitro compound. So we are taking this isocyanates. We are taking that is isocyanate. Isocyanate upon hydrolysis. Isocyanate upon hydrolysis. Uh, just a minute. So this is the chemical properties of the isocyanate. Chemical properties of isocyanate. Okay, nitro compounds. Nitro compound preparation is here. Okay. Chemical properties of isocyanate. Okay. So this is the isocyanate preparation. Now we are discussing that is chemical properties of isocyanates. Chemical properties of isocyanates. These isocyanates upon hydrolysis. Isocyanates upon hydrolysis. What you are going to get? You are going to get amine. You are going to get the amine. Next, isocyanates upon reduction. What you are going to get? You are going to get that is secondary amine. Okay. Next, isocyanates upon heating at 250 degrees Celsius, you are going to get cyanates. You are going to get the cyanates. So this is the preparation properties of isocyanates. Isocyanates are prepared by treating alkyl halide with the silver cyanide, alcoholics, and you are going to get isocyanate. It is prepared by the unsubstituted amide on POCl3, you are going to get isocyanate. Chemical properties of isocyanate. Isocyanate on hydrolysis, you are going to get amine. Isocyanates upon reduction, you are going to get the secondary amine. Isocyanates upon heating, you are going to get the cyanates. Okay. Next, let us go further. That is next type of organic compound, that is nitro. Okay. Next, you are going to discuss about this nitro containing compounds. This we are calling it as nitro alkanes. Let us discuss the preparation and properties of this nitro compound. Okay, preparation and properties of nitro compounds. So this preparation, these nitro compounds are prepared by taking alkyl halide and we are treating with the AgNO2. Okay, thereby this AgX will be eliminated and this alkyl group will be attached to NO2. We are going to get the nitro alkane. Okay, and we are taking an alpha chloro acid, carboxylic acid we are taking this. This upon heating with NaNO2. So here what happens, Cl will be eliminated and you are going to get the nitro compound. Coming to chemical properties of nitro compound. So this nitro compound on heating, you are going to get the nitrogen. Nitro compounds on heating, what you are going to get? You are going to get the nitrogen gas, carbon dioxide gas, hydrogen gas. Very important. So all these three gases will be evolved. So nitro compounds upon heating. Okay. So what you are going to get? Nitrogen gas, carbon dioxide, hydrogen gas. This is an explosion reaction. Next, nitro compounds on reduction. Nitro compounds on reduction is a reduction reaction. Okay, nitro compounds on that is reduction. What you are going to get? You are going to get the amine. You are going to get the amine. Next, nitro compounds upon reduction with the zinc dust. Zinc dust powered by NH4Cl. Okay. So what you are going to get? So you are going to get this compound. Nitro compounds upon reduction with the zinc dust, you are going to get a compound called, what is the name of this compound? The name of this compound is hydroxylamine. The name of this compound is hydroxylamine. Okay. Next, nitro compounds upon treatment with titanium TiCl3. What you are going to get? You are going to get aldehyde. You are going to get aldehyde. Clear? Okay. So this is that is preparation of this nitro compounds. Preparation as well as chemical properties. Okay. Nitro compounds upon heating, you are going to get three gases. Nitro compounds upon reduction with the that is tin in the presence of HCl. Tin in the presence of HCl, we are going to get amine. Suppose if you are doing reduction of nitro compounds in the presence of zinc dust and ammonium chloride salt, okay, you are going to get hydroxylamine. See this difference. So you are going to get amine upon doing reduction with the tin in the presence of HCl. Nitro compound will give amine upon reduction with the tin HCl. Okay, nitro compounds will give that is hydroxylamine upon reduction with the zinc dash and ammonium chloride. So these two reactions are important because we are doing reduction. Okay, but we are going to get two different compounds. One, we are doing reduction with the tin HCl, acidic conditions. Okay, we are going to get the amine, right? Other, we are doing with the neutral conditions. Other, we are doing with the neutral conditions. In neutral conditions, in the zinc in the presence of ammonium chloride, we are going to get a different compound. Okay, so when we are doing reduction of nitro compounds with in acidic medium, we are going to get amine. When we are doing reduction of nitro compounds in the presence of neutral medium, we are going to get the hydroxylamine. Okay, so this is that is preparation and properties of the that is nitro compound. So these two reactions you have to remember. Okay, so so two reductions are there. So nitro compounds are reduction in the acidic conditions, amine we are going to get. In neutral conditions means zinc ammonium chloride, you are going to get the hydroxide. Okay, understood. Is it clear? Please message in the chat box if you have any doubts. Please message in the chat box. Very important, this synopsis. Students, please message in the chat box. Students, is it clear? Please message in the chat box. Okay, let us go further. Okay, next screen share. So next we have this diazonium salts, aromatic compounds. Let us discuss this diazonium salts. So under this aromatic compounds, we are discussing about diazonium salt, aniline, and nitrobenzene. So these are the three compounds we are going to get discussed. Okay, what are the three compounds we are going to get discussed under aromatic nitrogen compounds, diazonium salts. Okay, next aniline and nitrobenzene. Let us discuss one by one. Okay, when diazonium salt is heated with copper in the presence of HCl, we are going to get C6H5Cl. This we are calling it as Sandmeyer reaction. When reacts with copper in the presence of HCl, we are going to get Cutterman reaction. When reacts with benzene, okay. So when diazonium salts when reacts with the benzene, what you are going to get? You are going to get the diphenyl. You are going to get the diphenyl. Okay, you are going to get the diphenyl. This reaction we are calling it as Bomberg reaction. So diphenyl. When it reacts with the phenol, what you are going to get? You are going to get the coupling reaction. Upon hydrolysis, what you are going to get? You are going to get the phenol. This upon treatment with HbF4. Okay, benzene diazonium salt. Okay, diazonium salt upon treatment with HbF4. We are going to get fluorobenzene. This is Balch-Skimman reaction. Balch-Skimman reaction. Next, preparation of aniline. How aniline is prepared? Aniline is prepared by taking benzene in the presence of NH2Cl and hydroxyCl3. You are going to get the aniline. Next, benzoic acid upon treatment with hydrozoic acid. So in the presence of constant H2SO4, this reaction is a conjugate reaction, and we are going to get the aniline. And that is phenol when reacts with the NH3. Okay, in the presence of anhydrous and Cl2, we are going to get the chemical properties. Aniline upon treatment with HCl in the presence of 0 to 5 degrees Celsius, you are going to get benzene diazonium chloride. Benzene diazonium chloride. Next, this phenol upon, this aniline upon reacts with the acidified KMNO4. What you are going to get? Aniline black. Upon reacts with alkaline KMNO4, you are going to get azobenzene. Upon reacts with neutral KMNO4, you are going to get azobenzene. So 3 different products. So acidified KMNO4, aniline black, alkaline KMNO4, azobenzene, neutral KMNO4, azobenzene, and nitrobenzene. Next, let us go for that is nitrobenzene. Let us discuss about the nitrobenzene. So nitrobenzene. So if you see this nitrobenzene, that is so I have given only chemical reactions here. This nitrobenzene on reduction, what you are going to get? Nitrosobenzene. This on reduction, you are going to get the nitrosobenzene. And this on reduction, again reduction, what you are going to get? Phenyl hydroxylamine. Okay, this phenyl hydroxylamine upon treat in the acidic conditions, this phenyl hydroxylamine on acidic conditions, you are going to get the aniline. Phenyl hydroxylamine on acidic conditions, you are going to get phenyl hydroxylamine on isomeric change, what you are going to get? Para-amino. So this phenyl hydroxylamine on acidic conditions, it will give aniline. On basic conditions, what you are going to get? You are going to get 3 different compounds: azoxybenzene, okay, azobenzene, and hydrozobenzene. Okay, azoxybenzene, azobenzene, and hydrozobenzene. So this is chemical properties of nitrobenzene. So nitrobenzene on reduction, you are going to get nitrosobenzene. This upon further reduction, phenyl hydroxylamine. These are acidic conditions, you are going to get aniline. And basic conditions, the presence of this reaction mixture, you are going to get azoxybenzene. This upon treatment with zinc NaOH, azobenzene. This upon treatment with zinc in the presence of NaOH, you are going to get hydrozobenzene. So this is preparation and properties of the nitrobenzene. Students, if you have any doubts, please message in chat box. Or if you want any repetition also,